Now we're going to talk about solving the quadratic equations by factoring. Let's begin with discussing the zero product property. Remember, product means multiply. We're going to multiply to make 0. How do you do that? If two numbers are multiplied to make 0, that means one of them has to equal 0. Either A equals 0 or B equals 0. Remember when we talked about factors at the beginning, and we said 0 is made up of something times 0. It can be 3 times 0. It can be 0 times x. It can be a times 0. Anything we want as long as one of the factors is 0. So if I'm going to solve an equation and I see that I'm multiplying factors and it equals 0, that means at least one of them has to equal 0. So maybe it's this factor that equals 0. Or maybe it's this factor that equals 0. It has to be one of them because that's the only way we make 0, is by 0 times something. So we say each of these could equal 0, and we solve each of those equations. This equation should get x by itself, subtract 1 on both sides, 2x is left, 0 minus 1 is negative 1, divide by 2, and x equals negative a half. The other equation, get x by itself by adding 5 on both sides, 3x, and 0 plus 5 is 5. Divide both sides by 3, and x equals 5/3. So those are our two solutions. X can equal negative a half, or x can equal 5/3. We could write it like that, x equals negative a half, and x equals 5/3. We could also write it in our solution set, negative a half and 5/3. Number 9 is also written as a product of factors that equals 0. So that means that either this factor equals 0 or this factor equals 0. One of them at least has to equal 0. Well, this one's already got x by itself. This one doesn't, so we have to solve for x. We'll add 1 on both sides, and x equals 1. So there's our solution. X is either 0 or 1, and it can be written with the squiggly brackets. What if we encounter a quadratic that's not factored? Then we might need to factor it. But remember, it has to equal 0 first. This says equals negative 10. So first, we will add 10 to make 0. Add 10 on both sides. On the left side, that makes x squared plus 7x plus 10. Remember, these are not like terms, so we just write them next to each other. The right side makes 0. Next, we need to factor this. If I have a trinomial, we can factor by grouping. So let's look at the leading coefficient times the constant. 1 times 10 makes 10. What multiplies to make 10? That adds up to 7. How about 2 times 5? 2 plus 5 makes 7. So our factors are going to be x plus 2 and x plus 5. We still have equals 0 because we started with an equation, so we continue writing an equation. Now we take each of our factors, x plus 2, and set them equal to 0. And x plus 5 equals 0. Solve each equation. Subtract 2 to get x by itself, so x could equal negative 2. Subtract 5 in this equation to get x by itself, and x could equal -5. So our solution set is -5 and -2. Maybe you pause the video, try number 11, and come back and see how you did. I see that it equals 0 already, so that's a good start. But I see that we have a common factor of 2. 2a squared, 16 is 2 times 8, and 30 is 2 times 15. So first I'm going to factor out the GCF of 2, and left over I have a squared minus 8a and plus 15. Keep writing equals 0 because we still have an equation. Now I can factor what's left over from this trinomial. So let's think about what multiplies 1 times 15. What multiplies to make 15, because 1 times 15 is 15, and adds up to -8. How about -3 times -5? That means our factors of this are a minus 3 and a minus 5. Let's keep writing our equals 0 because we're solving our equation. So now we'll take our 3 factors, 2, set them equal to 0, a minus 3, set it equal to 0, and a minus 5, set it equal to 0, and solve our equations. But 2 can never equal 0. That's not going to give us a solution. This one, we can add 3 to get a by itself. A equals 0 plus 3, 3. And add 5 to get a by itself. And a can equal 0 plus 5, 5. So our solution set is 3 and 5. Let's take a look at one more, number 12. W squared minus 64 equals 0. Well, I notice this is a difference of 2 squares. W squared is W times W, and 64 is 8 times 8. So this follows our pattern where we can write W minus 8 times W plus 8, and then of course equals 0 because this is an equation. Now that we have our 2 factors, we'll take each one and set it equal to 0. W minus 8 can equal 0, and W plus 8 could equal 0. And then we'll solve each equation. Add 8 to get W equals 8, and subtract 8 to get W equals -8. So now our solution set is -8 and 8. Take a couple of minutes to describe how the process of factoring a difference of squares is similar to factoring trinomials. See you in class.